It's tempting to think that the journey from sediment to sedimentary rock ends when the loose particles are deposited in a depositional environment and are no longer in a state of motion. However, sedimentary layers can be altered in many ways after deposition, up until the point of lithification, the process that cements the particles and creates the solid rock. Indeed, sedimentary layers can be deformed and modified as long as the sediment remains soft. With this in mind, let's talk about post-depositional structures, which are examples of secondary sedimentary structures. You may recall that primary sedimentary structures are created by processes during deposition of sediment. They are created up until the point where the sediment is no longer in motion. Primary sedimentary structures include things like bedding, bed forms, ripples, dunes, cross-stratification, and other things created by processes of sediment transport and erosion. Because erosion only applies to particles that exist prior to deposition, you can only find primary sedimentary structures in clastic rocks. In contrast, secondary sedimentary structures are post-depositional features of rocks that were created when processes affected sediment after it had been deposited. Often enough, these structures interrupt the continuity of strata because they distorted the sedimentary layers in some way. You can find secondary sedimentary structures in all types of sedimentary rocks, not just clastic rocks. So what sort of structures are we talking about? Post-depositional and secondary sedimentary structures are created by many processes. Let's start with a familiar one. Rain. Rain is one of the simplest examples of a process that creates a secondary sedimentary structure. When rain drops fall on soft mud or silt, they leave indentations and craters on the surface of the sediment. Over time, these craters may be filled by other sediment, which may eventually undergo lithification and become solid rock. When you split a rock like this one, you will see that one part has bumps, while the other piece, the counterpart, has indentations and craters. These indentations are called raindrop impressions. Raindrop impressions are just what they sound like. These secondary sedimentary structures form when rain falls on soft sediment, like mud, and the drops leave their mark. Interestingly enough, heat also creates a secondary sedimentary structure in clay-rich sediment, like mud. In hot environments where water can evaporate from sediment exposed to the air, the mud dries out over time. As the sediment dries out, its volume begins to shrink, and fractures begin to form within the sedimentary layer. These cracks develop a polygonal pattern, making it seem like the mud layer is broken up into plate-like pieces. We call these structures desiccation cracks or mud cracks. They form when clay-rich sediment dries out and contracts, creating these fractures. Desiccation cracks can become secondary sedimentary structures in rock if they are later filled by sediment, such as silt or sand, which subsequently undergoes lithification. Often, pieces of the mud will break off and become clasts in the sedimentary layer located above it. We call these clasts mud chips or mud flakes. Similar fractures form in clay-rich sediments and muds deposited underwater. When clay-rich sediment is deposited underwater beneath layers of sand or silt, it gets compacted under the weight of the overlying sediment, and simple or slightly curved tapering fractures form in the mud layer. At the same time, the cracks are filled by the sand or silt from the upper layer. We refer to these fractures as Syneresis cracks, and they get preserved in sedimentary rocks. Unlike desiccation cracks, they don't have a polygonal form to them. They generally appear discontinuous and somewhat randomly oriented throughout the rock, so they don't look much at all like mud cracks. That said, both Syneresis cracks and mud cracks form for the same reason. Clay mineral particles tend to stick together when they experience changes in moisture or salinity. For this reason, the sedimentary structures only form in sediment with high clay mineral contents, like mud. Of course, there are many other types of post-depositional and secondary sedimentary structures that form in entirely different ways and can be found in many other types of sediments and rocks. Life forms can create a variety of secondary sedimentary structures. For example, a plant can grow and extend its roots down into soil and other soft sediment. When the plant dies, the roots are decomposed, leaving various voids and cavities in the soil. If the soil is then buried by sediment, the soil will become a type of rock called a paleosol. Eventually, as the sediment begins to undergo lithification, minerals will precipitate within the root cavities, creating sedimentary structures called root traces. Usually, where there is one root trace, you find many. If you find a sedimentary layer with root traces, it's a good bet that you're looking at a paleosol, an ancient soil. Much like plants, animals also produce sedimentary structures by moving through sediment. Many types of animals on our planet spend at least part of their lives living and surrounded by sediment. And a great number of these animals are extremely active, creating tunnels and burrows through sedimentary layers in search of food, mates, and other resources. In the process, they rework the sediment, they mix it. The mixing of sediment by organisms, like these animals here, is called bioturbation. Bioturbation has two important consequences. The first consequence of bioturbation is that it destroys sedimentary bedding structures, like laminations in fine-grained sedimentary rocks. As you increase the amount of bioturbation, laminations become harder and harder to identify because organisms have mixed the sedimentary layers together. You won't find laminations in rocks and sediments that have experienced a lot of bioturbation. They're too well mixed. The other, more direct consequence of bioturbation is sedimentary structures of burrows, trails, and trackways of bioturbating organisms. Burrows preserved in rocks are trace fossils of animal activity as well as sedimentary structures. Although life forms do produce a variety of sedimentary structures, they are by no means necessary for sedimentary structures to form. Many sedimentary structures are simply created by physical processes like erosion. An important type of erosion is called scour. Scour is the removal of soil, rock, or sediment by a flow that moves over it. Scour is responsible for the removal of sediment that leads to the formation of rivers, streams, and submarine canyons. These features are called channels and are yet another example of a secondary sedimentary structure. Channels form when sediment, which has been deposited in a place, is removed as a flow cuts down into the earth and removes the sediment. The flow, in turn, becomes confined within the channel. Overall, channels come in all shapes and sizes, ranging from meters to kilometers in width, length, and depth. But scour also produces various other types of smaller sedimentary structures called soul marks. One important type of soul mark is called a flute or flute cast. These structures begin as asymmetrical and tapered depressions created by turbulent flows that move over soft sediment, scour the surface, and remove material. As a flow continues to scour the surface, the flutes grow over time. Naturally, the depressions may be filled by sediment that gets deposited on top of the layers. And then the layers may undergo lithification to become solid rock. Today, if you split the rock open, you find the depressions which we call flutes. On the counterpart, likewise, you find the rock that formed from the sediment that filled in the depressions. We refer to these structures as flute casts. Most flutes and flute casts are centimeters wide and centimeters long, but they can get much bigger. You will sometimes see them called gutters and gutter casts if they are very large, on the scale of centimeters and meters. In any case, these soul marks have a distinct look and appearance. And because they are asymmetrical and form in the direction of flow, you can use them as a paleocurrent indicator. In other words, you can use the flutes and flute casts to determine the direction of the flow that produced them. You can figure out the direction of the current that existed in the depositional environment in the past. The flow always goes from the narrow but deep part of the depression to the wide and tapered end. Erosion can also indirectly create sedimentary structures through the use of tools. There are various types of tool soul marks, but in general, they are all created when an object, like a clast or shell, is carried by a flow and leaves some sort of mark or indentation on the surface. These indentations may be long grooves called drag marks, or alternatively, they may be round indentations caused by the saltation of grains across the surface. We refer to these tool marks as prod, skid, or bounce marks. A final group of secondary sedimentary structures that you should commit to memory are called soft sediment deformation structures. Simply put, soft sediment deformation is any change in the fabric and layering of soft sediment. It is generally caused by differences in density among sedimentary layers. Prior to lithification, soft sediments tend to contain a lot of air or water, which causes sedimentary layers to behave like fluids or liquids when they are under pressure. Due to this behavior of sedimentary layers under compression, Events sometimes trigger them to deform in ways that end up disrupting the lateral continuity of the layers entirely. It generally isn't hard to identify sedimentary rocks with soft sediment deformation. They tend to look really strange. It is, nonetheless, often very difficult to determine what exactly triggered soft sediment deformation in the first place. Geologists have distinguished many different types of soft sediment deformation. Some soft sediment deformation structures are created when a layer of higher mass and density is rapidly deposited on top of another, causing the lower layer, the less dense layer with less mass, to buckle and expel its fluids up into the layer above it. Other ones are created when sedimentary layers are deposited on a slope or incline, and this leads to sedimentary layers flowing or slumping beneath others. Vibrations caused by earthquakes can also liquefy sedimentary layers and make them behave like a fluid for a short period of time. In fact, there are too many different types of soft sediment deformation to review here. For now, you should just be mindful that you may encounter soft sediment deformation of one type or another. At the end of the day, the best reason to learn about the origin of a soft sediment deformation structure is to encounter it in the field.